Welcome back to functions again. In this next section, we'll talk about section 4.3, which is actually the graph of a function. If there's nothing else you remember from this part of the notes, please remember that whenever we sketch the graph of a function, it's not just the graph that we want to talk about, look at the expression of the graph, we also want to take note of the function's domain. I give you a quick example. I don't think it's difficult for all of us to sketch this graph like that. X squared minus 3x. You are well capable of sketching it because it's a quadratic graph. If I want to sketch this graph, x squared minus 3x, where gx is actually y is actually x squared minus 3x, I don't think you can do badly there. I want to highlight then that this is what is important. Take note of the domain, because if you realize what I sketch here, I'm only sketching the positive values of x. So if you can see, it is a U-shaped graph, but when I'm excluding the value 0, I'm excluding this section. The tempting thing to do is to sketch this graph where you think it's sketching this only without taking into account the domain. Next, I want to talk about section 4.4 of your notes, the range of a function. Given a function, we can actually determine the range of a function. How do we do it? Essentially, is to look at the graph first, then use it to determine the set of all possible y values. I say again, if you want to find the range, let's use this as an example. If I want to find the range of it, this one, I want to find what are the possible y values. That gives me the range of the function g. So here, to find the range of f, draw the graph, then determine the set of all possible values of y. You may read example 4a and b on your own. I'm going to pause here for a while because you should be able to do it on your own. I'm going to resume in 5 seconds. Let's look at example C. I will go through example C with you. Find the range of this function over here. It is not difficult to sketch this quadratic, so I will assume most of us is able to do this. Sketch this quadratic here from 0 to 5. Now, after you sketch from 0 to 5, here, from 0 all the way to 5 is a quadratic graph like that. By observation, you can see that what are the possible values y can take. It is actually from a minimum value of 12, this is 12, all the way to a maximum value of 28. Right? So therefore, you will refer to chapter 0 in terms of notation, right? C chapter 0 for interval notation. Okay, you want to include 12 and all the way to 28. So a short way of writing it sometimes is range of f is equals to 12, 28. You can also do that. Now, I want to emphasize the importance of the graph, because if you don't sketch the graph and if you don't realize that there's a minimum point here at 112, you will never get the correct answer. If you do this, some of us, this is a wrong method. I want to emphasize this is a wrong method. Some of us may say, oh, okay, never mind, I substitute 0 in. F0 is actually 13. I sub 5 in. F5 is actually 28. I substitute this in. Then you wrongly conclude, I repeat, you will wrongly conclude the range is from 13 all the way to 28. Why? Because you assume that the graph is a straight line in orange from 013 to 528, when actually it is not. When actually it's a quadratic like that. So I want to caution all of us, do not do this method. And I want to emphasize that you must look at the graph of a function before determining the range of a function. Thank you.